What is up, YouTube? Today I'm going to talk to you about Kotlin Coroutines, which are a really cool part of the Kotlin programming language. So you just have to import a new package, and then you can run things in background jobs and things in asynchronous code blocks. That way you aren't blocking your main thread either in your Android implementation or in your background or like backend server, blocking and waiting, making the user wait for different operations. So let's jump into it and I'll show you exactly how coroutines work and a couple of examples to get you started. All right, so to get started, you need to import something like this. The version may be different, but essentially you want org JetBrains Kotlin X and then Kotlin X Coroutines core. This will give you a bunch of different functions. You can see from the import statements that there are 3 of them here. So delay, launch, run, blocking. And before we jump exactly into this, what exactly is a coroutine? So in its most basic form, it's essentially a thread mixed with a function. So a function takes some inputs and gives you an output, which is going to be kind of your launch right here. The CoroutineScope, which is this run blocking, this is the suspendable piece. In languages like Java, you actually use things called threads. And so that is something that runs in a certain context on the processor, and it doesn't interfere with anything else that's also running in the different processor threads. But for Kotlin, these are more lightweight. And so these are lighter weight than your typical threads, which is why you can run a lot more coroutines than you can threads on your system. These will run in the background and then get put down and spun back up whenever it's running on your different processor cores on your computer. Essentially, coroutines can do everything that a thread can do, just they're a little bit more lightweight and a little bit more efficient. But there are some attributes that you should know about when using coroutines. And those are, they are executed in a thread. So they are separated from other parts of your code and they're not going to mix and match. They're suspendable. They will execute, wait, and then resume. And the last one that you really need to pay attention to is they can switch context. Whenever you spawn a coroutine, it doesn't mean it's going to run on the same thread. And so if you write code that you're relying on it running in the same thread, you're going to have a problem. So assume that everything is going to run in multiple different threads, and then you won't run into problems. All right, so now let's talk about the pieces here. So run blocking and launch are both coroutine builders. They essentially are going to allow you to put together this coroutine and run it on your system. So if we run this, we should see this output below, which is hello and then world. And we should see this delay happen, even though world is here first in the process. It's not going to be printed first because we're launching a coroutine. Delay is actually a special coroutine function as well. So usually you would have something like sleep in here if you were doing a thread or some other development. But delay is the thing that you need to use whenever you're waiting inside of a coroutine. If you needed to spawn several coroutines, you can actually use something called join and wait for all of them to finish and complete. So let's say you wanted to send out a bunch of API requests, then this is how you could wait for all of them to come back. So this highlights again that this is a job. And so you have this launch and this is actually a job. And then you can wait for those jobs to all be completed. So we would see hello world and then done, because we're waiting on everything to be completed. If we had a second job, then we could do something like job 2, and we could wait for this other job 2. And so if we wanted to wait for both job 1 and job 2 to complete, then we just have this list of both of them, and we use this function join all, and that'll wait for all of them to come back together and output. We've talked about needing to have different jobs within your run blocking or your coroutine scope. Whenever you're running within a coroutine scope, that's actually called the CoroutineContexts. And so a job is also paired up with a dispatcher, and both of those in combination are the context that the coroutine is executing in. Now, you can actually switch out the different dispatcher depending on what kind of job you want to run. There's actually 4 different kinds of dispatchers that you can use. The default is going to be called default, and then you have IO, main, and unconfined. Generally, you don't really see unconfined used a whole lot. It just means that the coroutine is not confined to run on any specific thread. But for our example here, so let's say we have a really expensive database query. So we can define this job to be on the dispatcher of the IO. And then this job can be on the dispatchers of main. This you usually will see in Android applications, but Just as an example here, these are two different ways you can define the dispatcher depending on the operation that you're running. If you like videos like this and you want to see more Kotlin stuff, like and subscribe, and I'll see you in the next one. Thanks.